This video is about different things that you can do with my gear template generator program. The program is for designing gears and then printing accurate paper templates so you can then stick them on a piece of plywood and cut them out on the bandsaw. The program automatically updates the gears on the screen if you change any of the parameters, such as the number of teeth, or for instance we can change the pressure angle of the gears, which will substantially change their shape, or for instance we can change how long the various gear teeth are. So there's a lot of options that we can play around with on these gears. Now what's important is that the gears actually mesh successfully, especially if you actually intend to make some of these gears out of metal. So let's zoom in on the area where we're meshing, and let's show the line of contact, which is the line along which the gears contact, and let's turn off the animation just so we can see. So the way involute gears actually work is, imagine that we have here a string being unwound from this wheel and wound onto that gear, and the angle at which it's unwound is actually the contact angle here. So as we change that, you can see that changes this angle. So the gears are always pushing along that line, and we want to make sure that the next gear tooth is engaged before the previous one disengages. So let's rotate this gear manually, and now watching here we can see we're getting to the end of the engagement right about here, and the next one is already just barely engaging. So these gears will stay fully engaged, they won't wiggle. If you were actually building a real machine like a car transmission, you'd want to have at least 2 engaged, but if you're making wooden gears, this is actually quite sufficient. If we change the pressure angle, we can also change that engagement too, although sometimes it makes it worse. You can go more extreme with a small number of teeth, but the smaller the number of teeth, it really becomes difficult to engage. So if we look here, although these will continue to run, they'll be a little bit rattly because they don't fully engage. Now if we go to lantern type gearing, so just select pin here, we can actually go fairly extreme. Now let's make that pin diameter smaller, and we'll make the shaft hole in the middle a bit bigger because that's shortening our teeth a little bit. And now if we rotate that through here, you can see this here continues to stay engaged up until about here. By that point the next pin is fully engaged. So we can have fully engaged with just 4 pins on here. Now if I change that to 3 gear teeth on the lantern, and let's get rid of that shaft hole, so I'll just set that to 0. And now if we rotate through here, if we see here, that becomes disengaged here while the next one is not quite fully engaged yet. So those gears will work, but they'll be a little bit rattly. Now one of the cool things this program can do is it will calculate gear tooth undercut. So notice a round thing in here. That's because the let's rotate that. That's basically the round in here is making space for the other gear tooth to kind of get in here. This is new to, well, I added that in version 2, although the previous video didn't cover that. As the gear teeth become more square, that undercut becomes extreme. So this would be a very rattly set of gears. But let's see, that would kind of barely work because this would push it far enough on here, and it would kind of catch the next one. Let's make that 4. And this can get quite extreme if I make the gear teeth a bit longer in terms of undercut. So this is a very funky looking, very fragile gear, but for a do-nothing machine that could be still kind of a fun thing to do. The undercut is most severe with small gears. If I make that a bit bigger, see, that becomes much thicker already. Another cool feature of the gear program is, let's zoom out a bit here, is the ability to put spokes on the gear. So if we go into spokes, we can select how many spokes we have on a gear. Now a gear does need a minimum number of teeth for the spokes to show. So if we have too few teeth on there, the spokes, there's just not enough room for spokes inside. And the detail level of the spokes is determined by the size of the gear teeth. So the more gear teeth we have, the more room we can do for spokes. Essentially, the spoke thickness is determined by the tooth size. So if we make that tooth size a bit smaller, notice these spokes become thinner. And now for larger gears, you'd probably want to have more spokes. Quite a few. You can also change the size of the shaft hole. Let's make the other one a bit bigger. The shaft hole, depending on whether you want it in there or not, if you set 0, that makes it disappear. But you can specify the size. And in here, if we make it big enough, the hub also needs to expand a little bit. Now, if you're cutting these gears out on a bandsaw, you don't so much want to use a circle to cut it out. You'd much rather just have a mark in the middle for where it goes. So if we click on Show Center, that turns that on. And there's other annotations. For instance, we can show the pitch diameter of the gear, which is the whole thing with a line of contact. And other things, we can draw the lines a little bit thicker. That's been a requested feature by some people, because the lines can be quite thin sometimes, or faint depending on your printer. So it helps to make them a little bit thicker, just to help with cutting it out on the saw. Other things we can do is we can add a little bit of slop. If you're making the gears on a CNC machine, you can't really compensate that well. So now let's add a little bit of slop. So this is essentially, let's zoom in on here, that's adding a minimum amount of spacing between the teeth. So this is a rather extreme amount of slop. Personally, I just rely on the width of the line, and I cut right to the line, and that works out nicely. But if you find your gears are a little bit too tight, you can use that parameter to control the slop. The program can also do ring gears, and you'd use that for planetary type gears. So for instance, if we make that middle one a bit smaller, and that'll look better with a bigger angle. So we could have a gear in here, a gear here, and another gear here. As the gears have very close to the number of teeth of each other, that starts to get a little bit funky. So let's make that one smaller. And we can run into issues where we have a little bit of interference here. The program doesn't check for that. So if you have very close to each other gears, that can be a bit of a problem. Although, if we do the cycloid lantern type gears, then you don't have that issue because the program fully calculates that. And that gets very funky as the number of teeth has the very close number as the other one, especially as the number of teeth becomes much smaller. So that can make for some very funky gearing. And if you look in here, the pins of the lantern are fully engaging all the way around, so there's no slop in here at all. Now, another cool feature of the program is it can calculate block chains and roller chains, but I'll cover that in a separate video. Now, next thing is we can save the parameters. Not very exciting. For printing, let's do a print preview on here. So here we have our gear thingy here. Typically, if you want to cut the gears out with a scroll saw or a bandsaw, you don't really want to show both of them because that's just messy. So let's turn off display of that one and turn off animation. And let's also make that one a bit bigger. And we'll make the pins a bit bigger and more teeth. So if we want to, let's do that print preview on that one again. It still fits on a page. Let's zoom out here. And let's make that 30. Print preview. Now you see if it doesn't fit on a page, it will split it automatically across 2 pages. And the grids really help to align it. But what's really useful with the grids is there's a grid diagonal feature, and let's make that grid a little bit coarser. And let's do a print preview again. And 2 pages. So when you print both of these pages out, all you have to do is make sure these lines become straight, and you know you've got exactly the right spacing between them. And so you can go across many pages. There's really no limit to how many pages you can go across. So let's make the gear even bigger. Oh, that still fits on. Let's make the teeth a bit bigger. And now it's across 4 pages. And again, we can use the grid diagonals to line everything up. And we can go across as many pages as you want to. The biggest limit really is how much paper do you want to use. Now, next thing is the units. We can work in inches, centimeters, or millimeters. I personally prefer working in centimeters. It doesn't really change much how the program functions. It more changes how the output is scaled. So if we change this gear to inches now, and we do a print preview again, that will go across quite a lot of pages. Unfortunately, I can't show that many pages all at once in the print preview here, but you can see here. Now, I've had pretty good success just cutting gears out on the bandsaw, but some people prefer to use the gear program with CNC machines or with laser cutters. And this is where the export menu becomes very useful. So we have DXF export with polylines, which is slightly more advanced than the earlier DXF export I've had, but some CAD programs have difficulty with it because DXF is kind of a horrible format, and I may have not done it quite right. So if you have problems with the polyline, just use the basic DXF export. You can also export it as DAE files, which the free version of SketchUp can import. You can export it to HPGL, which some programs like CorelDRAW can import. You can export it as CSV. That's basically just comma-separated values if you want to do something with the numbers yourself. Or you can export it as an image or as a PDF, which is intended mostly for using with laser cutters. So you can then take that file, and on some laser cutters you can just use the PDF straight. But let's export this as an image, and we'll do it at, say, 50 pixels per centimeters. So let's export that. And let's have a look at that image. And the lines are 1 pixel wide. Sometimes you might want to have thicker lines, so if we turn on draw thicker lines, and let's export that again as a image, and again 50 pixels, and we'll call that gear 2. And now look at that image, and we can see the lines are actually much thicker. Now, next thing is there's help. The help is included with the program, but there's also online help that you can check out without actually buying the program. The program is unfortunately not free. You do have to buy it, but the eval version can do pretty much everything that I've just shown you here. The only difference with the eval version is it has wobbly mode turned on. The idea with wobbly mode was I wanted to have the eval version have pretty much everything enabled, but I still had to give you a compelling reason to buy the program. So the eval version essentially distorts space, but other than that, it's fully functional. So you can still use the eval for doing things like checking whether a certain pair of gears will mesh nicely and will work, but it's as though everything was looked at through a swimming pool. So if you printed these gears out, they would not mesh successfully. So one major feature of the program that I haven't covered is chain mode, and I'll make a separate video covering that.